Good morning, and thank you all for taking the time to make it out today, and we'll get started here. Get stuff rolling right. So it was 1834 that the first patent was filed on a corn planter, and since then farmers have been progressing and improving their consistency and their yield potential till the point that for this last season the record was set of 616 bushels per acre. We all have the opportunity of managing the resources that we've been entrusted with, and looking forward to the coming season, it's how are we then going to manage and prepare those in order to make the most of what we have to work with. Historically, when it comes to planter maintenance, we typically end up just running after what's the easy, low-hanging fruit, the simple known problems that we're experiencing, and to be able to step in and solve those. But the question and the risk of that is, what if we're not looking at the right problem? What if there is a more expensive problem that we're overlooking because we don't know it's there? So the content for today is going to be a little bit different, of being able to look more of what's the agronomic components of the planter pass, and how can we be a bit more astute and aware and do the best with what resources we already have. So as we look through the agronomy of the planter pass, your first component is going to come down to emergence and such. We'll start off, work back through some of the yield risks on that, and then work more in detail into the emergence side of things. Within emergence, there's quite a number of subsets. The first one is we have to be planting into moisture. Once we've achieved moisture, we have to ensure that that furrow is free of residue. Once we've cleared that, then it's a matter of, are we planting at a uniform depth? And then to be able to ensure that that furrow is closed in such a way that we have that uniform density and that stuff's able to emerge evenly. And in our environment, it's not as critical as further north, but we still need temperature to fuel that entire process, and remaining aware of what's going on there. And then we'll touch a little bit back on singulation and a little bit more on spacing. So in working through and looking at what are the yield risks that are on the table, when it comes to emergence, corn is fairly susceptible to a yield loss. It ends up coming down to just under a bushel per hour variance between the first spike and the last spike. So if you have a field that takes 2 days to end up coming up, we're looking at about somewhere between 40 and 43 bushel per acre left on the table just due to emergence. And we've already taken that off the top of what that seed's capable of. When looking at cotton, the yield impact's a lot less. We've seen up to about a 38% loss in yield, but the challenging thing is cotton is 10 times more valuable than corn. So on an economic standpoint, we got a lot more at stake in cotton than we do corn. When looking through the risks on singulation in corn, if we're missing a plant, we're going to be somewhere around that neighborhood of that particular plant is going to produce 80% of what it could. Being it's missing, the plants on either side are going to pick up about 10% each. In cotton, the plants do end up putting on more lint, but when we start looking through, okay, how much area does this plant end up occupying? We start dividing that out, we're still running about a 22% loss in there. If we have an extra plant in corn, we're going to, with that competition, limit what those plants are capable of, and so we're going to run somewhere about a 40% hit of what that plant could have produced. In cotton, running about a 7% impact in regards to how both plants end up setting fewer bolls and such of that nature. When it comes to spacing, this is the least, or area of least economic impact. And so in corn, we can see up to about a 20% loss in yield potential when those plants are misplaced, depending upon severity. On the cotton side, we are seeing something, but it's right on the edge of statistical relevance, and so we're not going to really be talking about that until we get enough to warrant diving into that further. So to start off, we're going to dive into emergence. As we look through the economic risks there, this is the most expensive and at-risk component of that planter pass. And in order to have a crop to harvest, we have to get it out of the ground, and we have to get it out of the ground uniformly. When thinking back through very specifically, so in corn, we can lose up to the full yield potential of that plant, because if it ends up coming up late, the plants on either side don't have the advantage if the plant wasn't there. It's still using some water, it's still using some nutrients, and so we're going to set ourselves back there a bit. So roughly that just under a bushel per hour loss on corn, and on your cotton side, they're up to about 38%. When looking at emergence, we look at all of the factors that go in and can influence that crop getting out of the ground. The first and most important is we have to have moisture in order to feed the germination process. Once we've cleared that, we have to ensure that it's free of residue, because residue can end up impacting it very similarly to not having moisture at all. Then we have to ensure it's at a uniform depth so it has consistency of time to be able to make it out of the ground. And in that making it out of the ground, that we have a mellow path of the surface and we're not hitting different impedances and such along the way that's going to hold us back, and then adequate heat to fuel the entire process. When planting into moisture, we have to think about moisture from the seed's perspective. It takes 30% as seen by the seed of moisture imbibed in order to start the germination process. The risk is, as we look at different soils, it's going to vary in regards to how accessible is that water to the plant. In sand, water is very readily available to the plant. You can apply very little to the field. It's very available to the plant. You get into clays, we have to apply a lot more because of the way that it ends up holding on to that due to the additional pore space and such there. But the ultimate goal is we want everything to germinate at the same time. Looking at the different factors that can influence and negatively affect that availability of moisture is, we're going to start back at the previous harvest, is are we distributing that residue evenly? Because if we have thick mats and no residue, we're creating variability in regards to underneath the residue. We're going to have moisture, most likely, depending upon the winter. We're going to have more accessible in the profile there versus where the sun's been hitting it all winter long and the winds have been affecting it. We're going to be a lot rougher shape. The next component, as we're looking through different factors prior to planting, is if tillage is involved, we've got to be very careful in regards to how is it affecting the environment that we're trying to ensure we're ready for. So as we look through, anytime we're touching that soil with a piece of tillage equipment, we are drying it out and we're increasing the risk of unevenness in there. As we look at different tillage passes and the effects that they have on the density of that soil, if there's a density change in there, what moisture is down deeper cannot make it through that boundary layer that's created, and we can't get that moisture back up to the surface to improve the uniformity of what that plant can have accessible. The most detrimental aspect that we can have out of tillage is going to end up coming down to is if we have clods or larger voids, because we don't have that soil kind of firmed down to the necessary point where that we can keep that air out of there. We want enough that the soil's healthy, but if we have too large of pore spaces, we're going to end up fighting with additional drying of that soil and less than ideal environment going into planting. So when looking or summarizing the impacts that we need to be careful to manage prior to planting, we want to be careful in regards to how even is our residue, and if we're involved in tillage, how are we managing it in such a way that we're going to be careful of it. When looking at the planter pass and thinking through, okay, what moisture do we have to work with? We need to have it consistent so that it's accessible to that plant. If we're going up and down, we're going to have some seeds in moisture and other seeds out of moisture. And what'll end up happening is any moisture accessible in that soil, the seed is going to begin the imbibing process. It will not germinate until it hits that 30%. And so if we have moisture and then run out, that seed's going to make it up and stop. And if we end up having others that are, say, a little bit more moisture, they're going to make it further and then stop either until a pivot comes through or whatever we're going to apply to that. And so we're creating variability going into that. One interesting thing we got looking at on that on a pivot a couple years ago, and it kind of happened by accident because we weren't setting out to identify this, is we had a guy that we had planted one half of the field, started the pivot, and then went and planted the other half. Is running roughly a 3-day loop. We're early June coming in behind some wheat stubble. And we came back once this started coming out of the ground, we started looking, okay, what are we at on the side that was planted first, where that pivot was turned on within a matter of an hour or so. And we started walking through there, and we're seeing, okay, fairly little. We got 2 bushel an acre left on the table due to minor planter errors. We get over to the other side and we start walking through there, and it's like we're running up more in the neighborhood of 6-7 bushel an acre. It's like, what's going on? And we started digging around and looking through there, and you got short plants, tall plants, short plants, tall plants. What ended up happening is it was lining up with this previous tillage pass. We had left soil looser and then firmer, looser and then firmer. The capillary action came up in those firmer areas. That germinated or started imbibing immediately, versus the rest of this was 3 days behind. So we start working that through. On that particular operation, they were running about $18 an acre difference between the $18 an acre difference averaged across the field. It was 32. You cut that in half between the field. Per 1,000 acres, he was leaving $18,000 on the table. When we got that much at stake, we can figure out how do we create an even environment for that plant to be able to operate within. When looking at even moisture, we have 2 different options when we're coming into an uneven environment. The first is run a loop, bring that moisture level back up to an area that we can manage, or basically let that soil dry down so that the seeds won't all end up germinating, and then from there we can be able to keep that seed staged a little bit better opportunity. When looking at the planter, we can have everything perfect in the field as far as moisture, but when it comes to the planter, there's a number of maintenance things we need to keep aware of on there that if we're not maintaining those, we can end up undoing a good round of uniformity to that field. The first of which is your gauge wheels. We're wanting those gauge wheels running up there snug enough in order to prevent dirt from slipping up in between and rooster tailing in there. So we'll look at this next one. And you'll see if we have anything along these lines, we have a serious problem unless you're throwing wet dirt in this environment. Because that dirt's going up, falling straight down to that trench before the closing system's even gotten to it. And so we could have perfect moisture down there, and we just created a massive amount of variability to that environment just due to a simple maintenance issue. So working through on those gauge wheel arms, there's basically 2 courses of action you can enter into. If stuff's still tight but just out of adjustment, we can be able to adjust that in. Or if we've simply worn stuff out, there's different aftermarket solutions. We can go in, load that entire assembly up, and be able to not have to replace those parts and be able to ensure we're not going to end up limiting that. On the case side of things, a little bit more difficult. We need to go in there and get some thinner washers so that we can be able to keep that tire up against the disc blade, and then be able to provide additional washers on the outside before driving that roll pin back in to ensure that that wheel's kept snug and such in there. Once we've perfected all of those things and protected that, as we start looking basically from the disc blades on back as that planter is rolling through the field, we have to be careful in regards to how that furrow is formed. And this is a very tricky and very poorly understood component of the planter pass, and something that we have failed in understanding and educating you guys on in the past. When it ends up coming down to it, we can have good moisture, but if we're not keeping that furrow intact, we can let that dry dirt up on top slough right into the trench, and we'll get to that here in a second. As we look at, and I should say the foundation of getting to that is we have to be planting at the depth that we want before we can start managing to this. So kind of the initial bit, kind of what's an average of what you guys are running as far as corn depth? Okay. And how about for the cotton guys?
3/4 inch.
Okay. Anybody going deeper on cotton? I think you guys are inch and a half, up to inch and a half, whatnot, so a little bit of variance there. So once we've identified, okay, what's the depths we're going for, how do we end up ensuring every row unit is running of that consistent depth? And it ends up coming down to your depth system. As things end up wearing, we end up with variabilities into there. So what we want to do is before each season, for your two different depths, assuming that you're running two drastically different depths, say for your corn, if you're running, say, that 1.75 or 2 inches, what you'd end up doing is basically taking a block, we'll look at this next one here, we took a block that was 1/4 inch taller than what the operator was wanting to plant at. Got 2 of them, threw them underneath each gauge wheel. We're going to bring the depth handle back down, and we're going to slide both these underneath the gauge wheels like so. Just put stuff up, slide it down. Planter's level on concrete, parallel arms are level and such there. Once you've done that, we'll come up on top. We're going to lift the handle up, and then you're going to index for that depth. You're going to grab the nearest hole and whatnot, so kind of split your averages there. And then if you're running a shallower depth, to be able to go down and, if you're running that 3/4, get a 1 inch material, put it under each one, repeat the process, do a different color index so you have differentiation between your two depths. Once we have ensured that we're putting it the correct depth, then we have the ability to ensure that our disc openers are running at a consistent depth. The trick here is, in order to reach depth, we have to be carrying weight on the gauge wheels because it's running up against the stop in order to create the consistency. The challenge is we now need to firm that trench so that it stays intact, but without over firming it and creating compaction and root limitation issues. And there's different control systems to be able to manage that, but the following is an example of what we do not want. So as he starts slowing down here, and notice how that dirt starts sloughing in there, is if we had moisture down deep, we just created variability. If you're planting perfectly dry, not as big of a deal, but it's when we get into that deal of where we have moisture and then not having moisture on the surface that we want to be caring for that carefully. As we look at what it takes in order to form the furrow, this is an example of what a furrow needs to look like. If you took off your closing system and pulled forward a little bit, we should be able to just go in there and just, if we touch the sidewall, that should crumble, but it should stay in place until then. Otherwise, we're mixing that and creating variability. There's a number of different components that go into how much weight does it take on the gauge wheels in order to make this happen. And this is kind of where we've gone astray in the past, is we've said, okay, the most important thing we need to go after is we need to hit depth, but we weren't managing the amount of margin that it takes in order to achieve this. So there's kind of two different scenarios in regards to how much weight is it going to take in order to form this. The variables which are going to require less extra weight on the gauge wheels is if we are working with heavier soils and we have a decent bit of aggregate stability and structure to that ground. And the higher your moisture content is also going to aid in this process. And then finally, the faster you're planting, as you saw there, once he started slowing down, we had more sloughing. In theory, the faster you end up going, stuff ends up staying in place before that closing system hits it and brings everything together. On the flip side, the environments that require more excess weight on your gauge wheels in order to form this furrow correctly is if we're dealing with lighter soils, particularly sand, if we're dealing with poor aggregate stability, ground that's been tilled and just there's no structure left to it, and if we're dealing with a drier environment and we're going slower. And so we have all of these variables stacking up in there. Basically the only tool we're left with in order to manage the more difficult environments is to be able to utilize water as our friend, both from a standpoint of improving access of moisture on the seed side, but it's also going to make it much easier on the planter and the operator in order to properly form this furrow and such. So working things through and thinking about what it ends up taking there. Now, all of this is true for your Deere, your Kinsey, and your White. Case is a little different. On Case, the Case engineers went in and put these reduced inner diameter gauge wheels on there. Those wheels are extremely critical to the design of that system. In order to make that work, we have to, now mind you, this is in a full tilled, adequate moisture environment, we have to carry a minimum of 150 pounds on that gauge wheel in order to boil that soil up into that RID so that you're left with a ribbon that's about 1 inch to 1.25 inches higher than where the gauge wheel ran, and it is taller than what you want your seed depth to be. And this is a portion of how that has to be prepared in order for the Case closing system to even work. The challenge we end up running into within this is if we're dealing with soils of any level of structure or anything lower in moisture and anything close to a no-till, we do not have enough weight on the bar in order to make this row unit function the way it was designed. These were designed for Central Illinois, good moisture, full tillage. We start taking it any side outside of that, we're getting really, really difficult conditions in order to make that thing perform the way that it was designed to. In order to conclude the protection of that moisture, we have to be mindful in regards to how we're closing that furrow. When we bring that soil back over the seed, we want to protect the density of that soil so that the seed can make it out uniformly, but we also do not want to allow it to be left too soft, because we'll end up kind of similar to if you have clods. We have the pore space, we can have drying of that soil, and so we have an opportunity with the closing system from a water management perspective to be able to basically create the optimum density so that we minimize evaporation, and yet we're not over compacting it and impeding the emergent side of things. One thing to be aware of is thinking through different types of closing wheels. We ran into an issue this past spring with the Schlegels, is due to the aggression of that, is when you have a dry duff on top, good moisture underneath, we've seen that basically just boil that soil up, drop dry dirt all the way to the bottom. We go scratch back, we got dry bands on both sides and dry dirt down the middle. And we've just impeded that seed's ability. So be careful with how the closing system can end up affecting leaving that optimum environment. To kind of recap the components when looking through managing moisture surrounding the planter pass is if we can plant into good moisture, we're going to be left in a much better situation. If we're dealing with variability and such, utilize the pivot that's already there, look into pre-irrigating that and be able to maintain decent level of moisture going into that. Take care of your gauge wheels, make sure those things are set in there correctly so we don't have that dry dirt dropping down in there. making sure we're calibrating the depth system each year to ensure we have the consistency across all the rows so that we have that carbon copy, and get out and dig. This is the thing we have not done enough of, and we have to be out there, we have to be looking. We will not learn, we cannot take corrective action unless we know what's going on. And so we need to take the time, and we're going to try to make a much better effort this spring to be out with you guys, helping you dig and working through this education process so we can try to better care for what resources we have. And understanding how the closing system interacts there and making sure we're working within that. The next component of managing emergence, it's still tied to moisture, but it's a little bit different in regards to residue. When we have residue near that seed, the residue is going to absorb water at a much faster rate than what that seed can. And so that residue is going to collect as much water as it can, and then once that process is done, then the seed is going to begin its imbibing process, and so we can create variability when we don't have that set right. So here's an example of throwing some residue against some plants, and then they let it grow, and you can see what ends up happening here. So in looking at the two different groups, the ones that had the residue, we ended up with about a 31-hour variability within this example between the first spike and the last spike. The other side, it wasn't perfect, but we did get it down to more like a 10-hour differential. So we start taking this and looking at against the yield loss, we're like a 29 bushel hit on those plants that were surrounded by residue, versus we're only running about a 9 bushel hit for those that were in a bit more of a optimum seedbed environment. When looking at kind of a field level, what is the yield impact of residue next to that seed? Up at a research firm in Illinois, they went through, took the closing system off, went and planted, and they had the interns come in a very controlled fashion at different rates across the field, applied residue, and then took it to yield, and was able to generate this chart to be able to see we're running about, for every percentage point of residue increase, we're going to knock yield by about 1.1. It's kind of the real world implications on that. And so we start looking at residue. How do we end up getting it into the environment? So the first of which is tillage. Horizontal tillage in particular is about the worst that we can have, because when we're rolling that dirt over, we're mixing residue right in with it, and it makes for a very difficult environment. Vertical tillage can do it as well. It depends upon how stuff's ran, and we're going to put strip till rigs into the same category. The way that any form of tillage this is going to apply to is that shank boils dirt up, we're typically throwing dirt on top of residue. And so we've already created mixing. And then as we start getting into finishing passes, it further ends up mixing in there. One of the only rescue options available for tillage is some sort of a filled cultivator of sorts, or any sort of an S-tine shank where we got some vertical movement. It has the ability of lifting some of that residue to the surface. We cannot undo the problem. Once it's created, we're stuck. But there are rescue options there. Row cleaners are a good tool, but we have to understand what's their limitations. And the best out there can only clear residue out of the top ½ inch. And when we got a seed zone that's up to, say, 2 inches deep on corn, we're going to have a problem if we have residue mixed into that ½ inch on down through the seed and such. So we want to be very careful while we're running, if tillage is involved on the operation, get out, dig, see what things are looking like, and do what you can to manage that if a tillage pass is needed. When it comes to row cleaner design, there's a lot of different wheels out there. They can basically be split into two general categories. You have the one on the left here. The air to steel ratio of that one does a really good job of being able to move all residue, be able to move all residue that it touches and yet not move any dirt. The shark tooth on the right, it's going to move absolutely everything that it touches. There are certain environments that's okay, but we can generally end up creating furrowing and just create a lot of additional variables within that environment. Once you furrow down, you run the pivot, lighter soils, you just change the depth when that dirt washed back in over it. So we want to be very careful of thinking that through. When looking at row cleaners, the other thing we want to be mindful of is as topography changes in the field, in order to maintain engagement, we want a floating row cleaner. It's going to be able to follow those contours better, make sure that residue is swept out of the way. When we get into varying loads of residue, we need to start looking into different control means of managing. Do we have enough weight, as it were, on that in order to blow that residue out of the way and not let the row cleaner go up and over it? And so there's different tools in the toolbox accessible to be able to configure and equip the planter to deal with the residue. While we're on the front of the row unit, we need to spend a little bit of time talking about coulters. For the most part, these things have gone away. There's still a few of them around, and the thing to be careful with on that is if they're running, to never run it deeper in the seed. Ideally, we want to run about a 1/4 inch shallower than the disc opener. The problem that we end up running into is if that does not cut what residue is out there, that disc opener has no chance of doing it because it has nothing to press against now. It has a 1/4 inch of travel. Versus before, if something would have slipped through the row cleaner, we at least had the depth that we were trying to shoot for in order to cut through that. Gauge wheels we're finding also have an impact on residue. The 4.5 inch one, and we actually should back up. The best row cleaners on the market only are clearing a path of about 9 inches. If you have two 4.5 inch gauge wheels on a planter, you have a footprint of about 11 inches. And so we'll watch this video here of some 4.5 inch versus 3 inch in no-till corn. And so what's happening is that row cleaner is throwing that residue out. Due to the width of the gauge wheel, we're running over about 3/4 of an inch of the lip of that, but then that residue is sitting right there against that gauge wheel, and as soon as that gauge wheel rolls up, that residue starts flying across that row. And we get in here a little bit, we'll actually see a stalk flying from the other side and completely cross the trench. And these row cleaners were fairly decent. They weren't managing stuff quite perfect. We had a little bit come through. Now versus a 3 inch, notice that residue staying more in place and not springing back over the trench because we're clearing out to it. It drops, the gauge wheel sweeps past it, but we don't have that tension against the tube because of the footprint. And we're able to leave that in a better environment. So kind of the conclusions on residue management is we have to do everything we can in order to ensure that we don't have residue in that furrow. And utilize tools such as floating row cleaners to be able to manage that. The next component as we start working down through is uniformity of depth. We can have everything situated well, and once we've cleared those, the next yield limiting factor within the emergence category is going to come down to depth. If we aren't running at depth, we're going to end up creating variabilities of difference in timing and such. The thing to be careful of is once we've achieved depth is what depth do we need to be running at? And there's different studies that'll end up coming out here like this that show 2.5 inches is your best yielding environment. Well, we end up getting into this, there's a lot that's not being talked about within that equation. What was the moisture they were planting into? If it was like this, we can see exactly how those results came to be. And we'll watch this as it grows for a second. So those up in the top right, which was planted a bit shallower, they didn't germinate because they weren't in moisture. We come down to the next deeper ones, we had some moisture, but not necessarily enough. We did end up getting some growth on that. Those that were deeper and had really good moisture did fine. We ended up taking these out to it. Those that were running shallower, it took 11 days for that to get out of the ground, versus we get into more of that midsection, planted shallower, it got out of the ground faster, versus those that were planted deeper, yes, they germinated evenly, but because they were deeper, we ended up taking longer to get out of the ground. So we want to be careful to manage. If we can manage our moisture, we don't have to go excessively deep and create more variability of more dirt for that plant to have to push up through. The interesting conversation within the topic of depth is there is some talk rolling around in regards to if we have roots above the ground later in the season, we need to be planting deeper. The challenge with this is when we look at the plant, if we're shallower than 1.5 inches, yes, we can end up pushing that plant out of the ground because the mesocotyl is too close to the surface, because as that plant germinates and comes out, once it senses the surface, 3/4 of an inch below, that's where it sets the first nodal roots. And then each nodal root thereafter, as it ends up working up, correlates with each collar on that plant up through VT. So when we want to be deeper than 1.5 inches so that we be able to maintain adequate length to that mesocotyl, but going deeper, we're only changing the length of that mesocotyl. We're not going to affect what roots are above the ground. Of the different maintenance items on the planter in order to manage getting those plants at a consistent depth is going to start with the seed tube guards. The purpose of these is to keep those discs held at an appropriate distance so that we're correctly creating that furrow. When these are new on a deer, they're 7/8 of an inch wide. When you wear down to 1/2 inch, time to replace them. If a guy's running wave vision, we want to replace them at 3/4 of an inch. There's a number of different aftermarket options out there of extended wear variant to be able to better solve that. The next component of consistency of depth, and all of this is assuming, because earlier we talked about getting the depth system calibrated, making sure we have adequate weight on that row unit in order to maintain depth. The next component in through here is going to be your disc openers. As those disc blades end up wearing down, we can end up leaving a ribbon there in the trench, or as those blades come apart and such. So when looking at different blades on your deer, when they get to 14.5, need to replace them. New's 15. For the Case 1200s, new was 14, and replace them at 13.5. New 2000 series, they're running 15s, so the same rule applies on that. And then the different variances depending on which series of white planters are out there and such. When new blades are being put on, we want to make sure we have the same number of shims on both sides so that everything's centered up in there. There's different issues we can cause friction if that thing's not set correctly. And so consistency on that. When we're going in and setting them, depending upon the thickness of blade is going to determine how much blade contact we have and such. And so we want to, on the 3.5 millimeter, down from that 1 to 1.5 inches, versus up on your thinner 3 millimeter blades, be running that 1.5 to 2.5 inches. The next component of depth actually is going to come back to our parallel linkage. As that system ends up wearing, those parallel arms are keeping that row unit level. As on the deer parallel arm, hardened bushing, soft arm, eggs the arms out as those end up wearing. As that wears, it allows that row unit to end up coming up in the back, and so we're changing the pitch of how that disc blade ends up sitting in the soil, and we end up creating some additional variability within what depth are we actually running. Once we've maintained all of that, kind of the next component through is, as we look at different soil structures, we can have everything formed correctly, and we get into the heavier soil, the greater probability there is of different bits of soil down near the bottom of the trench preventing that seed from falling to the bottom. So in that, the seed firmers will be able to firm those down in there and ensure we have those of a consistent depth. So kind of the recap in regards to managing depth is that we have our depth system calibrated. We have adequate moisture, because we start looking into it. If we don't have adequate moisture, we're going to have a lot harder time being able to reach depth within that system. And then on the maintenance side, making sure we're checking our guards every year, our disc blades, parallel arms, and then managing the seed firmers. One thing on the disc blades, say on a deer, we're 14.5 replacement point. If a guy is at 14.5 and you replaced him last year, you will not make it through another season. So do be thinking those through and staying after that. Next component working back through is going to end up coming down to managing the closing system and managing the density of the soil over that when we have everything else managed up to that point. Ideally, we're looking for somewhere around 50% pore space, where about 20% of that's water and 30% of that is air. The scale at the bottom of this is 0.5 millimeter. And so when we start looking at what are the structure of that soil left if tillage is involved and thinking through, it does not take much to end up creating too large a pore space, and we can end up having troubles in regards to leaving that optimum environment within there. The outcome we are looking for is a mellow path of the surface, and if we dig down and find that seed, we should not be able to find the disc blades. We shouldn't be able to see compaction from the gauge wheels, and we shouldn't be able to find the closing system within there. And that we have good encompassment of the seed and a perfectly mellow path up to the surface. One of our particular challenges in the high plains is we're in a bit of a drier environment, and we got a lot of wind. And so we start looking at, we've done everything well up to this point. The closing system has an opportunity to have an impact in regards to how do we manage water within this environment and moisture around the seed. If we leave it too loose, we're going to volatile stuff off, but it's a balancing act because we don't want to go too firm and end up either creating crusting or other delayments in regards to getting that seed out of the ground. There's a fair number of components to the planter that we want to be aware and mindful of in regards to managing that consistency on the closing system. So we're going to start off of, we got to make sure that bar is level. And I should say level to ever so slightly uphill. If we get anything less than that, we end up allowing that row unit to be slightly nose forward. We don't have the weight on the closing system that was designed and such there. If we're not running slightly nose high on your 3-point planters, extend the top link, roll that system back. On the 2-point machines, raise the 3-point linkage on the tractor, level that machine up a little bit, and watch it in the field. Don't just do it in the yard. Yes, we want to do it in the yard, make sure stuff's good and ready to go beforehand, but be watching that carefully once we get to the field. And on your deer bowers, that we're managing that front cylinder and be able to set the levelness of that bar. Because what we're going after is those parallel arms are transferring that weight into that closing system. So another point where we want to be careful and making sure that those parallel arms are in good shape and we don't have excessive wear in there. The other thing in thinking through is on the closing system, we want to make sure we're careful on the gauge wheel side. If we're carrying too much weight on the gauge wheels, we are going to make it harder on that closing system. We want just enough weight on the gauge wheel in order to correctly form the furrow, but not have it over-compacted so that that closing system has an easy opportunity to be able to bring that together. When getting into the closing systems, there's a lot of different options out there. The thing to remember is the outcome we're going for is that we cannot see that there was a closing system there and that that seed is uniform. The other thing we want to be careful of is that we're not have a risk of moving that seed once it's been correctly placed. And we don't want to be creating variability above that seed. Of the different closing systems that are out there, there's kind of a general range of physics to them in regards to, are we trying to kind of force that soil down? The challenge with the spikes is it doesn't leave a very consistent environment once that gets done. Yes, it can handle fracturing stuff up, but it's going to struggle. On getting into some of your more blunt ones, it's a slightly more aggressive than the standard rubber wheels, and it's going to struggle. On the disc versions there, like the case, that system was designed to once again work with that ribbon of soil that's brought above it. So we can't be necessarily taking a case system and going and throwing it on a deer planter because your gauge wheels are different, the entire environment's different to it. And we got to be careful with these because you throw residue at them, they're going to fall apart. It's built for a clean field. When we start throwing other variables at the closing system, we're going to run into additional challenges. Get into no-till, we have better stability of that soil. It's going to be just a bit more challenging, and any bit of variability is going to change, okay, how do we need to be reacting to this? And it ends up becoming very difficult. The plethora of closing systems that are out there, each one was created for kind of a specific environment to challenge a very specific situation. You start changing any of those variables, it changes the answer to that. We drug 7 different closing systems across 31 farms back in 18. We didn't quite get 31 different answers, but it was fairly close to it. It's just all over the place. You change a crop, it changes the answer. You change the other stuff, it changes the answer. So it's a challenging environment. Thankfully, there's solutions that are coming out now where we can be able to address it for the guys that are dealing with the variability. If the field's perfectly flat, everything's uniform, and you can run it, great. But when we start getting into this, we have other tools in the toolbox now to be able to go in and address that. The maintenance side has an impact over how this is run. We take care of everything coming up to the closing system. Within that closing system, as we get slop in there, the consistency of it staying centered over the furrow becomes jeopardized. And we want to take the time before each season to go in and set the planter down, pull forward, make sure that closing system's centered. And if it's off slightly, move it, get it adjusted, pull forward. It typically takes about 4 replications in order to get that system perfectly centered in, because it can look right, pull forward in the field, it changes the variables. And so take the time, do it, make sure it's set well. And then once we get to the field, get out and dig. The only way that we know things are correct or not is to get out and dig. On the topic of moisture, I dug this one up. So both these are planted at the same depth. The difference we have here is, do we have adequate moisture, or are we running a little short on moisture? So this is kind of fascinating. So we started with full profile there on the left, and by the time we hit emergence, we have good rooting depth, and our moisture finally starting to pull down as we start working through those cycles and whatnot. So, example of some of the things that can be done there. So the next component as we work through emergence is temperature. It's basically, consider it kind of the fuel or the throttle that determines how long does it take between planting and that crop being out of the ground. And so the risks, if we don't get it out of the ground within time, is we're going to run out of energy, or if we're in a cooler environment, we could get into the position where we end up, the cell walls of that seed end up bursting and we end up losing it and such. So one of the things that the guys further up in the Midwest use extensively is a saturated cold germ test. Something we haven't utilized down here, but we start looking at this and we start looking at when we're planting early and we need to roll, and we get into some of this data. It's not even planting early we need to know this. We'll find some scenarios here and we'll kind of work through how do you manage what's on the farm. So what we want to particularly look at off of this, we got 5 different hybrids here. That center column, this cold germ germination result for each of these different hybrids. When we start taking this, it's like, okay, what do we need to be aware of on this? Because you look at the left-hand column, everything looks pretty good. The worst we have on there is 95% germ, which is not preferred, but we can deal with that. But you take that same hybrid, and if that thing's at 50 degrees, you're only getting 77% of them plants out of the ground. For $20 for this test, we can then take your hybrids and start ordering how are you going to plant this spring. It's not that you don't plant that hybrid, but it's when do you plant it. And so if we can go in and take that hybrid that can handle cold temperatures, you need to get going early. We've got too many acres to get through or whatnot. Let's be intelligent here in how we do this. So if we need to get going, we can grab that hybrid A. It has 99% cold germ. We don't want to plant cold, but if we need to, this one can handle it. And then you start progressing the season out as we work through it in order to, how do we end up managing stuff so we don't end up good. We'll get into some weather data here in a little bit. The critical thing to keep in mind on corn is, so it takes 30% imbibing of water before we fire the germination of that plant. The critical times within that is 24 to 48 hours after that seed's put in the ground. If that moisture is cold, we have an issue depending as reported by that saturated cold germ test. Beans, more critical. Cotton, the data is very weak on this one. Beans, it's a legume, or I'm sorry, beans, it's a broadleaf. In general, broadleafs are not as robust of a cool weather plant as your grasses are. This one's going to be interesting over the next couple of years if we can try to build this data set out to understand, okay, how do we need to understand and manage cotton, and if we're where we're up further north here, where we're trying to push that planting date in order to get the yield, and even for the guys that are south of the interstate where you have a little bit more of a window, how do we best manage those resources we've been given? So we come in here, this is April of last year. That last week of the month, that's kind of an interesting deal. As we're dropping down, so our average temperature is dropping down to 50. Ideally, if we don't have stuff pushing after us, up there, say around the 24th of the month, if we have to get going, we can grab, say, that one that has the 99% cold germ, go ahead and start planting it. You get into the 25th, 26th, you can drop down, grab some of those that are a little bit more robust because we're going into a warming trend. So this is, we basically sit on the phone, watch the weather forecast, and you start making decisions and calls. How are we going to manage? Once you start getting in around that 26th, if you have to keep planting, you better switch back to the one with the highest cold germ rating because we're coming into a cold snap. And it's going to cool down. You put that one that has a 77% cold germ and you go in there coming in on the morning of the 28th, and we're cooling down through the day and into the following night, you can knock 20% of your yield potential off of that variety. It wasn't the variety's fault, you just planted it wrong. It's not a bad hybrid for the seed guys in the room. This is huge for how do you position your genetics to the customer. And on the customer end, demand these tests. If they don't do it, Midwest Labs, you can get this done for 20 bucks for variety, work stuff through. So that's April, that's pushing early. Doesn't matter in May, or does it? This was the 9th and the 10th of May. The daytime high is 51 degrees or 49 degrees. It can get cold in May around here, and we got to be careful. And this is from the airport in Amarillo. So don't think that you're south of the interstate, you get away with this. It's worse the further north we end up coming. So we end up looking at this block. It's like, okay, if we have to get it in the ground, it's pretty cold back there on the 3rd, coming out of that cold snap from the day before. As that drops down, it just leads right into the left half of that. And, okay, so we either shut down or we switch to only the varieties that have that good cold germ rating if we have to run. And then, okay, so we're going into warming trend. It's like, watch the forecast as you go in there to the 4th and 5th. Yes, it's warming, but what's coming? Can you switch to the other hybrid or not, or do you need to stick with the one? And certainly looking at how cold that is, do you even want to plant that one? And these are decisions that need to be made, but understand, depending upon the variety and susceptibility to germinating in cold environments, is that hybrid going to perform? And then certainly coming out of this, we start going into there around the 11th and 12th, we're finally going into a warming trend. And at that point, we can switch over to those 77% cold germs and be able to go ahead and put those hybrids in. It's not that you're not going to plant it. It's how are you going to prioritize and order the operation in order to not give up massive amounts of yield due to a simple management mistake.
How many guys today are actually getting this test done? Show of hands. Okay.
Of the seed dealers in the room, have you guys even heard of this test, and how easy is it for you guys to get access to it at a corporate level? Something you can go back and ask the guys on. But once again, from a service standpoint, the seed dealers that do step up to the plate and do that, there's a huge service or advantage over the seed dealers that aren't going to pay attention to that. So there's plenty of opportunities. Yes, sir.
Does the cold germ test change year by year on varieties if you plant the same variety?
Every lot is different. So if you have multiple lots of the same hybrid, run each lot. Because it ends up coming off of, so when it comes down to that cold germ, a portion of the susceptibility comes down to what is the pericarp intactness on that kernel. If you're coming off the butt versus the flats off the middle versus the rounds off the end, they're going to handle differently going through the sorting process, where that seed originates from, how is that combine set up that harvested that seed last year. There's so many variables to it. If you're planting 20 lots, we're $400. We're less than $1 an acre, or less than half $1 per acre for a 1,000-acre operation if you had to run 20 different runs through. If we can be able to adjust stuff, the yield opportunity, if mismanaged, far outweighs that cost and such. So another fascinating thing is, so we look through this, and let's back up here and look at the April. We're going into a warming trend that opening week of the month, and the organic guys, they're obviously already running, but we're starting getting into spikes in temp, and then there around the 11th, it gets cold and it stays cold for a couple days and then starts warming up. And so we start making a decision, okay, how are we going to manage this? So a very interesting chart here is, this is soil temperature to days to emergence. Is it worth putting that seed out early when those soil temps are 50? The thing that we're blessed with down here is typically we get a nice, decent swing between daytime high and nighttime low. The question is, at that 2-inch depth, how much thermal energy have we absorbed to be able to manage and keep that seed in the optimum? But if we can get to at least a 55-degree soil temp, we can get that seed out of the ground in about 6 days. And as it warms, it goes out further. But if you start getting down around that 50, we're 25 days to emergence at 50 degrees and such. So we don't have to watch this as close as the guys up in Illinois do, but we still need to be paying attention, and we start looking, okay, how do we manage, because every seed has the opportunity of yielding tremendously. And you listen to Dowdy and these others, they're saying 800 bushels possible and such. And these guys are very much managing what they have going on. There's a lot of opportunity at our plate. It doesn't cost us any more. We're not spending anything else. We're just managing what resources we have at our disposal. So as we start then going back through all of the components that make up emergence, we start off as we have to have moisture. Has to be uniform as from the perspective of the seed. Once we have that moisture, then it's a matter of ensuring that it is free of residue, because residue can have the same effect as inconsistent moisture due to the way that it's wicking and manipulating things there. Once we've cleared that, then it's a matter of getting that to a consistent depth and managing the weight on that row unit so that as we're dealing with those different variables, that planter's thinking for itself and micromanaging our weight so we're maintaining that optimum. And then to be able to uniformly close that furrow and ensure we have a mellow path to the surface. And then to be able to have that temperature to fuel that process, and ideally if we can have at least 55 degrees and then, or going into coming from 50 and going into that warming trend, we're going to set that seed up for a much better opportunity. Once we've cleared all those, the next yield limiting factor as related by the planter pass is going to come down to, are we getting one seed into the ground every time? And so go through and recap what's at stake. On your corn, when we are missing a seed, we're going to lose 80% of the yield potential that that plant could have brought to the table. On your cotton, we're looking there in the neighborhood of about a 22% hit of what that plant was capable of bringing to the table. And then when you have an extra seed, on the corn, you're dinging it by 40%, and on the cotton, you're dinging it by 7%. So when looking at singulation errors, or this failure to have one seed every time, it basically ends up coming down to, if we have a skip, we have failed to load the meter, and if we had a multiple, we have loaded too many seeds to it. And so it's a balancing act of hitting that equilibrium so we only have one seed every time. So as we're changing varieties, we're thinking through, okay, how do we end up managing and adjusting our vacuum, having the feedback method so we know what we're doing and be able to take those corrective actions and be able to find that. The factors that end up limiting our ability to achieve a uniform placement of those seeds, and it come down to wear in the meter. And we end up looking, okay, we got a number of different wear parts in there, and as this singulator was running against the disc, whether you're running E set or V set, we have some friction rolling in there. And as we watch this one, basically that singulator is sitting on the disc's turning underneath, we have a wear surface between the two. And what we need to be mindful of is this is why there is graphite in the E-flow blend that we end up running in these meters, is that ends up providing lubricity to that and protecting it. The talc in there is purely to cut static. We'll get into how that in spacing in a minute. But the amount of lubricant that's needed in there is only a 1/4 cup per unit of seed. And this is the same for corn, cotton, whatever your unit number is going to determine that. If we run into flowability issues, or we're in some harsher environments where we're dealing with excessive wear of the meter components, add pure graphite to it to increase the flowability within the system. For the CCS machines, throw about 3 cups in each tank and turn it on before you put a bag of seed into the spring. It's going to save you so much headache in regards to slick that system up, let stuff end up distributing through that. On the spacing side, there's not as much yield loss here. This is one of the lowest yield impacting aspects of the planter pass. Corn, we could lose up to 20% of that plant's yield if it's misplaced. Cotton, we're right on the edge of what is detectable. But looking through the factors that end up affecting spacing, going too fast is the #1 aspect that ends up influencing it, which this ends up coming down to a very delicate balance of technically, if a guy's in cotton, technically, there's nothing stopping him from speeding up as it relates to the effect on yield. The problem is, as you speed up, there is more more energy being applied against the disc opener, and so then your downforce management system has to work that much harder in order to maintain depth. And if we speed up and we start cutting that, we end up losing much larger, and we maybe misapply it to a spacing issue. It wasn't a spacing-based loss. It was a cause and effect of what happens when we speed up. The drive system is basically culpable for all other spacing-related issues in there. And so we go through the different components within non-electric planters. We'll get onto the electric side in a second. But basically every chain, every orbit motor, every bearing, and your pro shafts are a wear item. These things need to be inspected. They need to be made sure that everything's turning freely. And the clutches, some of you in the room, we've had a lot of fun with spacing issues due to clutches on these things. We've got to be careful. We've got to take care of this stuff. On the electric side, it's a lot simpler. You just got a simple gearbox. Still a maintenance item occasionally. Once you hit about 1,000 row acres, then we can worry about addressing those if we run into those issues. When it relates to spacing, once again, the purpose of the talc and why they originally threw talc in the Deere meters is when you have that disc turning against that vac seal, static is created. And to be able to provide an element that manages that static so that, assuming we've managed everything else right, our consistency of timing, because as that disc rotates around, that vac seal is a perfectly flat surface there at the 9 o'clock position. As that disc turns around, assuming it's turning consistently, vacuum is evenly cut, we don't have static, seed rolls off the disc uniformly, we're able to maintain it. Now, when we start getting issues with the drive system, is as that's turning, it's chattering, we're adjusting the timing between seeds. We get into the speed factor of the units physically bouncing up and down, we're adjusting the inertia exerted against that seed coming up against there. So those are all the factors that end up going into the spacing side of things. So to review everything that we've covered in a prioritized fashion for what we deal with in this neck of the woods, emergence is our most expensive yield loss. Getting that seed into moisture is the first step. If you aren't in consistent moisture, none of the rest of the stuff makes a difference. You could have perfectly close trench, we could have moisture or inconsistent moisture. We've messed everything up. We've undone all the work we've put into it. So taking the time, making sure we're getting into consistent moisture. Free of residue, once again, not impede that seed's ability to imbibe uniformly. Getting it all to consistent depth and caring and managing for that planter so that as variables are changing, those units are thinking for themselves, being able to keep that disc opener at depth based upon what your digging's been doing to be able to say in regards to how much extra weight we need in order to create the furrow, be able to maintain that appropriate amount of margin, not over compacting stuff, but be able to create that optimum environment. And to be able to ensure that that furrow is uniformly closed so that we have that mellow path to the surface and be able to work through there, and then making sure we're paying attention to the temperature issues and that we're staging that seed to actually have the energy it needs to be able to follow through, and then singulation and finally spacing. On the maintenance side of that, all of the components that we basically from now until the middle of March have the opportunity of fixing and making sure that these factors are not going to contribute to any of those agronomic yield limiting issues on the planter, is taking the time to look into your parallel arms. We'll look at a video here in a little bit in regards to what is unacceptable and how to test that. Making sure your seed tube guards are holding those discs apart. Making sure your disc openers are in appropriate condition to be able to handle what you're going to throw at it for that season. Making sure our closing system is aligned. Making sure that our meters are serviced, and basically kind of now through the middle of March, we'll be getting hold of you guys and going through the meters that are up for service for this season and making sure that side of things is ready to go for you. And then finally, your drive system to ensure everything's in good shape on that side of things. So here, this first one is an example of what your pair alarm should not end up looking like. And basically depending upon how the row units end up sitting, to be able to either lift up or push down, make sure stuff's tight. We have rebuild options for these to be able to make these things last a lot longer. As far as the gauge wheel goes, this is kind of an unacceptable means of slop within that system. Is basically just grab onto it. Are we able to maintain that consistency to stay up against that? With the planter in the air, you could be able to dive in and inspect your disc openers as well. Also on the disc openers, typically right here, right where that mouse is at, if there's not dirt on there, you will see historical wear marks of where that disc blade occasionally ended up touching, and you can see if you have a 1/4 inch of rust showing there, you're at 14.5 inches and the blades need to be replaced. So cheating way of doing that, but still generally go ahead and break one of the row units down, gauge wheel off, disc opener off, measure your disc blades, see where you're at on that. And then if we get to the next one here, here's what your closing system should not end up looking like. Because as you're going through the field, that thing can walk back and forth, and we can end up adversely affecting how are we pushing down on that seed, and are we creating a uniform environment for that. So kind of from all of that, what's the next steps in getting ready for this season? So you all have notepads and pens on the table. We'll work through, we've got 4 questions we'll work through here. We'll give you about 3 minutes or so per question to kind of think through your operation of, 1, what did you learn today? What ends up applying to your operation, and what are the agronomic issues that you've seen in the past that need some time and consideration to prepare you for the coming season? So we'll give you about 3 minutes here. And then the companion question to that one is, looking ahead for the 2020 season, what are the yield limiting risks that are specific to your operation and such there? So giving about another 2 to 3 minutes to kind of think that one through. And then this and the next two, this one and the question after it, think more broad to your entire operation, not just the planter pass, because as we start looking at how do you manage the resources you've been given, you cannot look at stuff through a tunnel vision. You need the perspective of the entire operation, of what are the projects that face you as far as an operation level, whether it be improvements, repairs, whatever, thinking across the operation and assigning a cost of inaction along with a cost of action of those known projects, so that you can start prioritizing and seeing, okay, where do you need to focus in order for best return on your investment? So we'll give about another 2 minutes or so to this one, and then we'll get to the last question. Then the final question is kind of, what is from that list, what are the areas that you need to focus on? And this is operational level. The planner may or may not enter into this equation, but thinking through as an operation, where do you need to put your energy and focus for best return on your time and investment going into the coming season? We'll give another 2 minutes to this and we'll kind of work through some wrap up. So then from this, over this afternoon and tomorrow, we'll work on following up with you guys and kind of seeing what you learned, what we can do to improve the value of this kind of training for you guys in the future. And then within the context of the planner, what is it that you need help with, that we can kind of come alongside you and be able to design a roadmap in regards to how to aid you in being ready for the coming season. An example of that is here coming out of this is, we need to assist you with a planner inspection, be able to go through and work through each of these different wear components and be able to kind of put together a roadmap and a kind of a list. Here's the stuff that needs to be addressed. Here's the different options, and be able to help guide you through that process. And then kind of once that's done, ensuring that all these maintenance items are properly cared for on the machine and put together in such a way that we're able to maintain optimum uptime in the field and not be inducing additional issues. Certainly meter service is a component of that, of making sure that that's ready to go. And for some of the more complex systems, we've got some additional tools such as the suitcase we have up here where we can do more bench testing on site to be able to kind of work through some of these additional more complex systems and make sure everything's tested and ready to go through there. You can mark your calendars for March 31st. This room, 9 o'clock again, we will do an operation clinic where we work through more of, based upon all of these agronomic issues that can influence yield, how then do we operate the machine in order to manage against those variables so that we're prioritizing our focus in the cab to make sure that planter's being ran correctly and getting the most out of that. And then certainly on kind of an, as you guys need, we're available to assist you in the cab of whatever, or I should say more of in the field of going through the nuances of your machine and making sure it's set up and set correctly to be able to mechanically handle against all of these variables and such there. And then finally, whatever in-cab refreshers are needed in order to keep you operational. This is kind of an example list of what we can do to help guide you through to that, but certainly kind of be more of kind of a one-on-one basis in regards to where you're at, where you need to go, and how we can assist you in getting there and such. In the process of doing so, we got Cole Grett we brought on here a couple months ago. He's over Dahlem and Hartley County. It'll be kind of your guys' primary contact going forward to be able to have additional boots on the ground and assist you within that. And then Joaquin in the back is assisting us south of the interstate. And at this point in time, I'll still be handling southwestern Kansas as your primary point of contact in helping you guys through this coming season and getting things ready to go for that.